I also would like to figure out the whole nest thing for like posting stuff. But welcome, Peter. Are you a globe earther?
Yes, I am.
Nice, Pete. Why do you do that? Why do you believe in the globe?
Uh, well, because I mean, the sun goes up and down.
Yeah.
Um, I would push back against you and ask, why are you a flat earther? Because um, from the content, from what very little content I've seen of yours, your flat Earth model is what I would describe as robothemism, which is
Robotham
yes, I'm sure you know what I mean by that. It's
Samuel Robotham.
Yes, it's very, very distinct from ancient
Yo,
flat
that
Earth
is
theory.
awesome, bro. That is
You
awesome.
think I'm kidding? I'm not. It is very distinct.
No, I know you're not kidding.
It
I
is
know it's funny.
very,
I think
very
it's funny.
distinct from ancient flat Earth theory. Ancient flat Earth theory was based on observation.
Okay, well,
Robothemism
hold
is
on.
not.
Let's not gish gallop and just like monologue. Let's try to have a dialogue.
Yes,
That's
yes.
the whole purpose of the live. Okay, so you don't think sunsets would work on a flat Earth because why?
Oh, I don't. Let me be clear. I don't think sunsets would work on a robothemist flat Earth. They do work on
Okay, well,
ancient flat
let's
Earth.
not. Okay, so you're gonna have to very distinctly explain what a Robotham flat Earth is then to me. So please help me.
A Robotham
What is
flat
that?
Earth is one where the sun never travels below sea level.
Yup.
Ancient flat Earth theory, every ancient flat Earth model I have ever seen or heard of conceived of a sun that traveled below sea level. That is
Whoa,
fundamentally
whoa, 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 whoa! Stop, 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 stop. So you think when you look at a biblical cosmology projection and the sun is in the sky and it rotates around the same altitude, you think that that's showing a sun going below sea level?
you're talking about. You said the word biblical, and then you said a bunch of stuff that I have never read in the Bible. So you're going to have to break that down a little for me.
No, biblical cosmology. If anybody just looks up the words biblical cosmology, you'll see a flat earth with a sun and the moon both rotating in the sky.
No,
They never go below sea level.
that's
So,
not
can
correct.
you hold okay, how would you explain it then? What does a biblical projection look like? Biblical flat earth
The
projection.
Bible doesn't discuss the shape of the earth. It discusses salvation and reconciliation with God.
Okay. So, obviously it sounds like are you a Christian?
Yes.
So, do you think the earth is moving?
Yes.
So,
Well,
what do you
wait,
think
wait.
about
Let
Psalms?
me say.
Hold
Let
on. What do you think about
I
Psalms
want to refine my
saying that
answer.
the earth is fixed upon its foundations, that
I
it can
want to
never be
refine
moved?
my answer. Okay.
You don't want to answer my question.
No,
Okay.
I will answer your question. I just want to refine the answer I gave already. The Earth is moving.
Okay.
The Earth is moving depending on what like what your reference point is. So, like, obviously, we all know that.
Wait. Whoa. Hold on. So you think for some people in one coordinate system it's moving, and then for another person in a different coordinate system it's not moving?
No, I'm saying that the concept of speed is relative. So, if you're in a moving vehicle, for example, and you
Hmm.
are just in a passenger seat and looking at another passenger in the same vehicle, those two passengers are stationary in relation to one another. This is perfectly intuitive. Whereas if they
Yeah,
turn
no,
and look
that
outside the
makes sense.
window, they're
But
moving.
not when we're talking about somebody being on the surface of the earth in your model, they'd all be moving hypothetically.
Only in reference to other celestial bodies.
It doesn't matter. Is the earth revolving around the sun at 66,000 miles an hour, bro?
In reference to other celestial bodies, then yes.
So in reference to somebody on the surface of the earth it's not?
Correct. Yes, that's correct.
What are you talking about, bro? What? Okay, so okay, let me hold on. This is crazy. I've never heard anybody say something this insane, and this X community is different for sure. Most people on TikTok won't say something so insane. So to
All right,
somebody
wait,
that's
wait,
on
wait,
the
wait.
surface of the
That sounded a
hold
little
on. I'm
bit
in the
like
middle of a
ad
sentence.
hominem to
Don't
me.
make me drop you, buddy. Don't make me drop you. Come on, dude. Let me finish my
All right,
point. I do just kick people when they interrupt me,
I'm
okay?
sorry.
That's kind of how I run things around here, so please don't interrupt. So, what you're saying is you believe the Earth is a ball revolving around the sun at 66,616 miles an hour on average, but to somebody on the surface of the Earth, it's not.
Okay.
right?
Yeah, that is correct in a way.
Oh my gosh.
It I would appreciate a little more respect. It sounds like you're calling what I'm saying insane, kind of out of hand. I mean, I think
Uh,
I don't actually know why you're saying that. It's perfectly coherent to me. Um, and
why is that coherent?
why is it coherent? I just gave you a
Yeah, how
comparison.
is that
So
coherent?
imagine someone in a vehicle moving down the road. If you are looking at another passenger in the same vehicle, those two passengers are not moving in relation to one another. But if you look out the window, then they are both moving in relation to everything outside the car.
Yeah, yeah, no, I get what you're saying. I get that you're saying that somebody on the surface of the earth is in the reference frame of the earth revolving
Yes,
around the sun.
exactly.
But it is a very I understand that. I understand relativity very well. I just don't understand why you're saying that they are not. If the earth is revolving around the sun, they are also revolving around the sun, whether it's an apparent motion that manifests into their reality. It's still happening in your model.
Well, yes, it is.
How do we know we're revolving around the sun?
Well, by observing the parallax of stars and things like that, it's much more difficult than establishing the shape of the Earth. That's why the debate over heliocentrism lasted for centuries longer than the debate over the shape of the Earth.
What is parallax?
Uh, you don't know what parallax is?
Oh, I very much know what
Okay.
parallax is. I don't think you do.
Oh, okay. All right. Well, parallax is when two objects appear to change by a
No,
different.
one object, not two. What? What do you mean two objects? What are you
You
talking
need
about?
two objects to compare the change in angular, like
No, so you don't think you can observe parallax over time in one star?
you would need some kind of frame of reference for like whether that star is changing like its angle in the sky.
Mm-hmm.
Maybe your frame of reference is the horizon at a given time of night or something, or the other stars around it, but you need some type of frame of reference to establish like whether that star has changed its declination
Well,
azimuth.
that's what I would say. I thought you were meaning like you're looking at two different stars. When the stars are fixed, you can't observe parallax in the stars because they're fixed. They're all fixed in relation to each other.
They're not
So you can
actually.
only observe parallax from an assumed position of your reference frame, meaning the terrestrial position on the Earth in reference to the star's position in the sky. And you measure that in arc minutes, arc seconds, things like that. And you measure that difference over
You just
time.
said the
So,
stars are all fixed in relation to each other. That's not correct.
yeah. Okay, what star? Why isn't Aries getting closer or farther away from each other as far as the stars in relation to each other? Why are they? Why do they call them fixed stars then, Peter? Why do they call them that?
It's because they're all relatively fixed in relation. I
Yeah.
mean, in relation to the motion of all the bodies within the solar system, their motions are extremely, extremely minute, and that's why it took centuries for astronomers to detect that parallax.
Yeah. So saying that it's extremely, extremely minute doesn't refute the idea that essentially they're staying the exact same. You would agree, right, Peter?
Well, I mean, okay, in a practical sense, for most pedestrian observations, yes, they're fixed. But to a disciplined astronomer who is like using very powerful telescopes and very disciplined methodology, then their parallax can be detected
Why have all the constellations stayed the exact same for thousands of years?
because the motions that we're talking about are extremely minute, just like I said.
You think that dark energy, how fast is the Earth or the universe expanding in your model? Do you know?
I would have to look that number up. I'm not a cosmologist.
4 times the speed of light. Do you think that that's slow or fast?
Well, that depends on what you mean by slow and fast. Those are relative terms.
What is the okay? Well, so the amount of like semantics that you're doing is actually pretty frustrating. I
I'm
really
sorry, it's
trying to make it a
important though.
thing. Hold on. Let me finish, please, Peter. Come on, man. I'm really trying to keep it chill with people. But when you have somebody like this that can't say that a speed claimed to be 4 times the speed of light, they can't say whether that's fast or slow. That's triggering. So, just so you know, in your model, the speed of light is the fastest
Oh,
possible
I know.
speed attainable. So, 4 times the speed of light is pretty
But you're
fast,
talking, yeah,
Peter.
yeah, it's fast, but you're talking about on cosmological scales. On cosmological scales, then
Doesn't
everything
matter.
becomes relative.
A speed is a speed, right?
You're you're talking about cosmology. Everything is different in cosmology because it
What changes when talking about speed in context of cosmology? What changes?
because things can that when you're talking about distance of like billions and billions of light years, then like a speed of 4 times the speed of light is, I mean, yes, it's fast in relation to like relativistic concepts, but it's, I mean, there. I,
Hmm.
I mean, okay, all right. I will grant to you that it's fast. We'll just say that. I will grant to you that that's pretty fast. Yes,
That's a good
just
idea.
for simplicity.
So, if the stars are expanding away from us at 4 times the speed of light, why aren't they changing?
Oh, what do you mean?
Why don't they get any farther or closer away from each other?
That the I think you're maybe you're confused. The expansion of the universe is measured from our point of view, which means that the whole Earth or the whole universe is expanding. To us, it seems to be expanding away from our vantage point, which means that this that motion, in particular, of the stars is directly away from our vantage point. That would not cause them to change position in the sky. That would cause them to get slightly smaller and slightly more redshifted over time.
So, are the stars doing their own independent movements around other black holes and stuff like that in your mind?
Um, I mean, there's only one black hole that we know of within the Milky Way, so you'd have to be talking about stars in other galaxies, which we actually haven't cataloged that many of those, unless you mean Cepheid variable stars or something. But yes, there are presumably many, many, many stars in other galaxies that are orbiting other black holes besides ours. Um,
So, why aren't the observable stars in the sky changing position relative to other stars? Why? I just want a simple answer, please.
because space is big.
Because space is big.
Yes, yes, because space is big. I don't think you fully understand how big. I really don't. If you did, you
Oh, I
probably
don't
would not
think
be a
you
flat
do
earther.
either. Okay, so no, I definitely don't believe in space in general. So, can you prove that the vacuum of space exists adjacent to our pressurized atmosphere? How do you help me understand that? How does that work?
Gravity.
What's gravity?
It's the acceleration downward that we experience from, objects that have weight.
So, gravity is an acceleration rate of mass to the ground?
Well, it's a force applied downward to all matter. So, in proportion to however big something is, or however much mass it has, it applies a uniform acceleration to all objects, measured at 9.8 meters per second squared at the surface of the Earth.
So, what would you call that force? What is that? Like, can you explain that to me with science?
It's called gravity.
What is gravity, though? Just saying, so I can attribute that acceleration rate to electrostatics, buoyancy, and density causing the acceleration rate. What would you say causes the acceleration rate?
Electrostatic buoyancy. What the heck is
No,
that?
no. Listen, Peter. Listen to the words I'm saying before you strawman me and make a fool of yourself. Electrostatics, separate from buoyancy, separate from
Okay.
density,
All right.
all cause why mass goes up and down.
All right.
All can explain it. Is the helium balloon an anti-gravity machine to you, Peter?
No, that's of course buoyancy.
What happened to gravity?
The air molecules are heavier than helium. That's why helium
Mhm.
rises.
So, do you think what is Occam's razor, Peter? Do you know what Occam's
Yeah,
razor is?
it's the principle that you take the theory with that requires the fewest assumptions that can
Hmm.
explain all of the observations.
Perfect. So, do you think me saying that buoyancy and density has a very intricate relationship with why mass goes up and down applies more with Occam's razor? It appeals more to Occam's razor, or would you say that gravity appeals more to Occam's
You're
razor?
describing gravity. I don't see why
No,
that's
no,
even.
no, no, I'm not. What is gravity postulated by Einstein in 1915? General relativity. What is the current? What is that? What is that? Do you know what that is?
Well, Einstein did change a lot of concepts related to gravity, but the
No, he
concept of
didn't.
gravity far predates Einstein.
What did Einstein say gravity was in GR?
Uh, I okay. I understand that you will disagree with Einsteinian gravity, but I thought we were talking
Do
about
you?
something of. Well, no, I agree with Einsteinian gravity, but we are talking about concepts that predate that you and I should be agreeing on.
No, no. The current model of gravity is separate from Newton's theory of gravity. You realize that,
But
right? It was
on pedestrian
superseded.
scales, it still works according to
It
Newtonian
doesn't
laws.
matter if it still works. Whatever the current model is the current model, right, Peter?
People still use Newtonian equations for pedestrian things.
Because Newton figured out the law of gravitation, which is just an acceleration rate. In
Exactly.
both
Yes, yes,
models,
that's what I'm saying.
yeah, yeah, yeah. So okay. You're really trying to stay away from GR, it seems. GR is the current model of
General
gravity. It's the
relativity.
current scientific explanation for
I mean, I'll
gravity.
be upfront. I
Yes or
don't
no?
fully understand general relativity. It's pretty complicated, and I haven't totally cracked that nut.
That's very honest of you. I can appreciate that. But I would hope that you see the philosophical problem with believing in the current model of gravity being Einstein's theory and not understanding it and studying it. Do you see a problem with that?
Well, only if you distrust those who do seem to understand it, which I mean, I respect that. If you make that choice, you don't agree with you don't trust the people who say that they understand it and that it's true. I do trust them. So that's what, brings us to a different conclusion. But I mean, if we're talking about Newtonian gravity, which still applies on most scales, then like we shouldn't even have a disagreement here because on your flat earth model, it's pretty much the same concept. Mass accelerates downward, right? I mean,
No, it's definitely different. It's way different. So on your model, let's see. I'll even concede, like we can even debate Newtonian. But I do want the audience to know when you are debating a globe earther, you usually keep them on GR. You usually keep them on general relativity because it's the current model. But even debating Newtonian mechanics of gravity, mass attracting mass is much different from me saying that things go up and down based on the core tenets of buoyancy, density, and electrostatics. Very, very different. Not at all the same. So we can agree. I agree that the law of gravitation exists.
you just think
It is
it's
an
an
average.
absolute frame of reference, like it's always down, not toward other
Sure.
mass.
Yeah.
Yeah, I
So
understand that.
thing, things fall at an average rate of 9.83 meters per second squared. But the theories, the theory of Newton and the theory of Einstein, explain with science why that causal agent happens. What is causing mass to fall at that rate?
Right.
I have a completely separate theory
Yes.
from Newton and Einstein, which follows Occam's razor much more than assuming the bending and warping of
All right. All
space-time
right.
or that mass attracts mass at infinite distances instantaneously. Because you would agree that Newton's model, he didn't have a time variable, right?
Right. Yeah. I mean, it wasn't until Einstein came along that people, would have conceived that at a astronomical distance, two objects might not instantaneously attract one another. So yes, I think that's what you're getting at.
Yeah, exactly. So that's why I tend to only discuss GR because it's the most current, most
Okay.
viable theory in science's mind, right?
And we could talk about like which concept of gravity is correct, but I want to point out that even with your concept of gravity, a vacuum can exist above the atmosphere because even
No,
if down
no,
is an absolute concept that and all mass like accelerates this toward this absolute direction of down instead of toward other mass, that still causes a pressure gradient in the gas that creates the atmosphere. So what
no.
happens to above that pressure gradient?
So the problem here is assuming the gravity exists in the first place, acting on the atmosphere. So I am my position, my model would be of a container. So can you show me a pressurized gradient of gases without a container?
Well, it would have to be, I mean, if it's an absolute direction downward instead of toward a central point, like the center of a sphere, then you would have to have it bound on the sides somehow, so it wouldn't, I guess, like spill out around the edges. Unless it's an infinite expanse of like
Sure.
atmosphere in all directions.
I do believe that I do hold to the understanding. Well, my personal belief and understanding would be that the Earth is an infinite plane. So I don't think that there's just an edge that you walk to and
Sure.
look off. So I can't verify that. So I wouldn't say 100%. I know it's an infinite plane, but it seems like the only viable solution to thinking about the Earth as a level place, as a flat Earth.
Okay. So basically, it sounds like you're saying there is some bounding surface, presumably the expanse that's talked about in Genesis 1 if you use the KJV or something, and that there's no vacuum because the atmosphere just totally fills that container, right?
Yeah. Yep.
But we still measure a pressure gradient. Do you deny that?
You can only have a pressure gradient in a container.
No, because if gravity, okay, if that acceleration downward were not an absolute direction, but were instead toward a point, then you could still also have a pressure gradient in that scenario. Just speaking from pure geometry, okay?
No, no, that's not really geometry. Geometry is math, but um,
Yeah, it is. I'm talking
you
about
just so
three-dimensional
basic.
space.
So Peter, I need like an experiment. How do you follow the scientific method to show that gases can adhere or stick to a ball adjacent to a vacuum? How do we experimentally verify that?
Well, I mean, you're kind of skipping a few steps here. Like, I'm not
No,
claiming.
use the whole scientific method, please.
Well, yeah, the shape of the Earth. So, I mean, my friend sent up a weather or a high altitude balloon up to 120,000 feet in the atmosphere, and we actually measured the curvature of the Earth. So, like, I, I don't have to trust experts to know that the globe is a sphere.
Do you think Neil deGrasse Tyson is a smart guy?
Yeah, he's pretty smart. I disagree with him on a lot of things, though, especially when it comes to philosophy and religion, but he's pretty
So
smart.
So they did math around the radius claim and circumference claim of the Earth and figured out that you wouldn't see it from over 250,000 feet. Based on the Red Bull jump of, um, what's that one Freemason? What's his name? Oh, I wish I had chat. I wish I had a chat that people could type. Felix Baumgartner. Do you remember the Red Bull jump?
I remember it, yeah.
Do you remember how high he jumped from?
I don't recall off the top of my head.
It was like 120 to 150,000 feet.
Okay.
And they had to come out and retract his statement saying that he saw the curvature of the earth because they did math around it showing that you wouldn't see it from that high.
Well,
So,
yeah, it would be difficult to see with the naked eye. You'd have to actually measure it at that altitude. You know how much I measured it to be at 120,000 feet?
hmm,
6 degrees. That does agree with the geometry of a globe.
what type of lens was used?
Panoramic. That's the only way because with a non-panoramic lens, then you've got too many variables in the equation. And I spent a whole week creating an equation, and I mean, you have to know how many variables there are. It matters what the field of view of the camera is. It matters what type of lens you're using, how much barrel distortion there is. All of those variables have to be taken into account unless you're using a panoramic lens or some other instrument that can measure basic angular distance to measure the drop away of the horizon.
So you saw some curvature from a lens, and that's all you need to believe we're on a ball.
We measured drop away. It's 6 degrees of drop away. It's curvature is the wrong term
What do
in
you
this
mean
case.
by drop away? Like, do you mean from the camera it dropped from the eye level?
Yes, drop away. So the horizon dropped from the orthodrome of eye level on the camera's celestial sphere.
What's the exact name of the lens you used?
That I don't know off the top of my head. I would have to text my
You
friend
should
who performed.
probably know that if you're gonna claim. Yeah. Okay, that's extremely telling. Figure that out and come back to
That
me.
sounds a
Obviously, if
little
you don't,
snide, Caleb. That sounds a little snide.
yeah, it is. It is definitely a little snide for you to claim that this was a panoramic lens that didn't use any curved lenses and not know the
Well,
exact
it was
name
a
of the lens
reconstruction
is
from
pretty
people.
bad. Wouldn't you agree that's pretty bad for you to make that claim that
No,
it
I
proved
don't.
curvature?
I don't agree.
Okay. Yeah, well, I guarantee most of the chat will. So anyway,
Sure.
how else do we use science to figure out that the Earth's surface is convex?
Well, by simply observing sunset or sunrise and comparing, time of day with someone in another time zone.
Okay, so let's go with the first postulation. Why do sunsets only work on a globe? Why is it exclusive to a globular model?
Because the angular rate of sunset is roughly linear.
The angular rate. What do you mean by the angular rate? Because it's definitely dependent on longitude and latitude line. What do you mean by angular rate?
No, if you measure a scalar speed of the sun across the celestial sphere, it's going to be constant no matter what your latitude and longitude is.
Okay, so you're saying the distance traveled is uniform.
Yes, if you measure an angular distance on the
Okay,
celestial
okay,
sphere,
now I understand what you're saying. Why is that exclusive to a globe model though?
because if you're claiming that the sun is simply traveling around at a roughly constant altitude horizontally over a horizontal plane, then you have to somehow figure in perspective and how it should be, um, there should be like it changing size as it gets closer or farther away, and there should
Yeah, it
be.
does.
It actually doesn't.
Yeah, I actually just made a video where somebody used the solar filter and filmed the sun
I saw
over
that
in a
video,
complete.
and
Yeah,
in
yeah. So what
in
was
your
wrong with that
comparison
video?
shots, there. Well, first of all, the difference in size that you showed was a matter of like a few percentage points, which is
Hmm.
not the difference in size that one would expect from linear perspective. And number
Okay,
two,
so how do you math out what you'd expect on a flat Earth when we don't know the distance to the sun? Why are you making that
because it
claim?
doesn't matter what the distance is, it
You don't
matters
think it
where it is
hold
in
on,
the
whoa, whoa, whoa,
sky.
whoa, 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 stop, stop, stop. Okay, the somebody quote Peter here. It doesn't matter what the distance from somebody on the surface of the earth to the sun is.
It
So it wouldn't
matters
matter if it
where it
hold
is
on,
on
hold
the.
on,
Okay,
hold on. Be patient, bro. I'll let you talk, Peter. Be
right.
patient. So it wouldn't matter if the sun were 2 miles away versus 60,000 miles away. It wouldn't matter.
Obviously, it would matter for some things, but it doesn't matter for
We're
linear.
talking specifically about size, Peter. It would it matter in relation to the size of the sun, the distance? Does the distance matter?
What we observe is the sun's angular position.
No, 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 no. Yes or no? I'm not going to let you just talk past me.
I'm
Does
not
it
trying to talk
matter?
past you. You're asking a complicated question and leaving out variables. I don't know whether you mean.
No, we're only talking about the angular size of the sun. Would the angular size of the sun matter if it were 2 miles away versus 60,000 miles away? The distance matters, right? When we're talking about the size.
Yes, if the physical size of the sun is the same in the two scenarios, then obviously the angular size would be different in those two scenarios.
There we go. Do objects at a further distance away from you change their angular size slowly or quickly?
Slowly. I saw your video. You were correct up to that point.
Okay, so when did I stop being correct?
Well, when you talked about the vanishing point, you said it just disappears over the vanishing point.
So
That
you would
makes.
agree that the sun size does change then,
Yeah.
right?
Oh,
Just it
no.
doesn't change drastically.
No, no, I don't agree that the sun size. Okay, it changes by a few percentage points throughout the year because the Earth changes its distance from the sun by a couple of percentage points. The orbit of the
This
Earth isn't perfectly circular; it's a little bit eccentric, but
Okay, so I think this would help. Do we ever see the true physical size of the sun, or do we always see the apparent size of the sun?
apparent size.
Okay, so it changes because of atmospheric conditions and also, in my opinion, it getting closer and farther away, right? It changes.
Only by a few percentage points, unless you've got some pretty strong refraction through the atmosphere.
Okay, so that is you conceding that it could work on our model because
No,
we're saying that it's far away from us. It's a pretty good distance away, so it changes slowly. So you just saying that, oh well, it only changes a certain amount. That's what we'd expect.
okay. I at this point, especially when I saw your video and you said it just disappears over the vanishing point, I have only like 5 or 10% confidence that you understand the concept of linear perspective. When it comes
Okay,
to,
what is Euclidean geometry?
I I don't know
You
what
don't know what
definition you're
Euclidean
expecting.
geometry is?
Yes, I know what Euclidean geometry is. I don't know how to give you a definition that you're expecting.
XYZ axis.
Okay, sure.
Okay, do we see in Euclidean geometry or hyperbolic geometry?
Yes, that's another term you used in the video that I remember thinking you didn't. That claim seemed uh, kind of incoherent. We do not
Okay,
see in hyperbolic
okay, let's keep
geometry
it
that
simple.
I know of.
So you acting like I don't know what I'm talking about is extremely triggering because I guarantee you don't know what I'm talking about when I've spent hours studying this and
Well,
reading scientific literature on this.
I've
What does
spent
hyperbolic mean? What does hyperbolic mean?
pertaining to a hyperbole or a hyperbole.
Make it simple. Can you
There's a
put that more simply?
there's a mathematical equation that uses, I think, like x squared and maybe plus a constant or something. There's if you have a
You're
coefficient,
joking, right?
it's an
Okay,
equation of the
so
form.
we've obviously showed everyone you don't know what you're talking about. A hyperbolic geometry is the study of curved lines,
So
right?
Caleb, can I just point out you just did the same thing to me that you said about was triggering when I did it to you? You just said I
Well,
don't know what I'm talking about. I was talking about a mathematical equation for a hyperbole.
okay, I didn't ask for a mathematical equation.
That's the definition.
I asked you to define hyperbolic geometry, bro.
No, you asked me to define hyperbolic. I don't know exactly what hyperbolic geometry is, but I know what a hyperbole is.
So you saying that I don't know what I'm talking about when talking about Euclidean and hyperbolic geometry, and then you admitting you don't know what hyperbolic geometry. Do you
Uh,
see the problem here, Peter?
all
Do you
right,
see the
maybe I
problem with
jumped the
that?
gun a little on that. Maybe I'll grant you that. Maybe I jumped the gun a little.
Okay, so and I appreciate you being honest with me, bro. I'm trying to have a genuine conversation with you, and I'm not trying to like
Likewise,
do a gotcha or anything. I'm trying to
I appreciate
genuinely
that.
get to a point with you.
Okay.
So basically, all that I'm saying, I won't. I keep asking questions. So essentially, what I'm trying to suggest is that we don't see in Euclidean geometry, meaning straight lines, because our eyes are curved lenses. We see in hyperbolic geometry. We see in curved visual space. This is the reason why, like train tracks, you'll admit if you go to train tracks and they go as far out to the horizon to the vanishing point as you can see, it will look like they're converging, right? It will look like those straight parallel lines will actually converge when we all know that they're not, right?
Yes, but I don't see what that has to do with hyperbolic geometry.
Well, this is why we have a vanishing point. This is very simply explained why we have a vanishing point. The ground ramps up because our eyes are curved lenses, and the sky ramps
Mm,
down, creating an apparent
no,
location.
that's not why. It's because our eyes are a single point relative to the distances. Each eye has a single focal or a single focal point inside the lens, and everything is seen from that point, and the rays of our vision diverge. That's why there's a vanishing point. That's why there's linear perspective. I don't know why you need to bring.
I thought there was a vanishing point because the Earth's curved.
No, 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 no. It's because there's a single point that we're seeing from inside our
What
eyeball.
is that's not very like I'm not trying to be rude, but that's not coherent to me. So just saying that there's a singular focal point inside of your eye and that creates a vanishing point, you're gonna have to like elaborate.
Sure. So like whether it's an eyeball or a camera lens, the you're taking your sample of light from your environment using a single point in space, roughly speaking. There's sizes of lenses, but in a practical sense, you're taking that sample of the light around you from a roughly a single point in space, and then
But
you know
again, it's not explaining why there's a horizon,
right.
why
So
there's an
I'm
apparent.
getting to that. So if you trace the rays of light have to converge to reach that point. So if you trace those rays backward, following the rays of your vision, those rays are divergent.
Okay, I get what you're saying. I get what you're saying.
Yeah.
That's explaining how we see in curved visual space, though. You're just doing a roundabout way of explaining how I explained how we see.
All right. All right. So maybe I misunderstood your term hyperbolic geometry.
Yeah, so it just means like straight lines become curved. In this is like point perspective, right? If you look down a hallway, I really wish I was on TikTok so I could show you like in a background. But if anybody in the chat, or if Peter, if you have like a computer next to you, if you just search the term point perspective, and if you were, let's just say me and you are standing in the middle of a hallway and we look down that hallway,
Mm-hmm.
all of the lines are parallel to each other, right? The dimensions, let's just assume it's a perfect hallway, all of the lines are staying parallel as they go down the hallway. Let's say it's a 100-mile long hallway. But as we are standing inside the middle of that hallway, looking towards the very end, it will look like they all converge to that singular point, like you're
Yeah.
talking about, that focal point, right?
Yeah.
So we both agree. So that's why we get that. That's essentially my theory of why we get a horizon and why it's apparent. Because if we were to zoom, right? If me and you were to sit in the middle of that hallway, put a P1000 on a tripod, and zoom down that hallway, we would expand the angular perspective of the quote unquote apparent horizon and be able to see further because the angular resolution is being increased, right?
I guess so. Yeah. I mean, I didn't follow every single word you said, but I think you're roughly correct. I agree.
Okay. Do you want me to define any of the words? Like, do you want
No,
which
that's
words
okay.
did you not understand?
Let's just let's just say yes. I agree.
Okay, so that's our explanation. That's a steel man of why flat Earth has a horizon versus globe Earth that says that it's the convexity of the Earth's surface at 8 inches per mile squared, right?
Well, you'd have a horizon on either model, and when your vantage point is essentially touching the surface of the sphere relative to the distances involved, then you'd have the exact same type of horizon. That
Yeah.
eye level orthodrome around your celestial sphere is
So
what it is.
it sounds like we agree. So I guess I'll route this back to why we started on this conversation.
Yeah,
So we started talking about this because the sun sets.
yeah.
So in my view, it's coming and going, right? It's coming, which is what we observe with reality. If we were to go out and have no preconceived notions, you would agree that we would observe a stationary Earth. If we just used our senses, right? We would feel a stationary Earth and we would observe the sun
Well,
moving
if
across
you
the
and I
sky.
had no preconceptions and also, didn't have, experts or whatever telling us that the Earth was a globe, we would probably arrive at an ancient flat Earth model of believing that the sun traveled below sea level, because
Okay,
that's the most direct implication of what we observed.
sure, sure. I guess I could see that. I've never heard. I'll be honest with you. I've never heard of a model of our ancestors saying that the sun physically went below the sea level. I've never actually heard that.
Really,
I'd be interested in checking it out,
I've
but
never
no,
heard anything
I've never heard
else.
of that. Where are you getting that from?
I mean, even just okay. I haven't studied a lot of ancient mythology, so maybe there's one that I'm ignorant of. But like, I
It's not
mean,
mythology; it's cosmology.
okay, sure. There wasn't a lot of distinction, in past millennia, but sure. Um,
I almost like when you look at the models, if somebody can put in the nest, how do I put shiz in the nest, dude? Somebody right now, I'm about to accept somebody to tell me how to put stuff in the nest because basically if you have like you've seen the pictures that flat earthers post where they're showing like all of ancient cosmology, like the Egyptians and biblical cosmology, stuff like that. Like you've seen those graphics, right?
I don't know if I've seen specifically what you're describing.
Okay, so there's pictures going around. Zach, I love this post that you. Dang, dude, I need to figure out. I'm gonna hold on. I might accept somebody. I know Shinku does this. Shinku's on this vibe. Yeah. Yo, Shinku.
Yo, Caleb. So
Yo.
how you throw stuff up in the nest is like you go to like a tweet and you like push like the share button as if you're gonna share it to somebody and it should pop up your space at the top for you to like slap it up there.
So if I go to Zach's post that he posted in the bottom right here about the vanishing point, I click on the three dots.
Or you could, or like the little share button, wherever's next to it,
Yep.
and it'll pop up. Like right now, I can share something right now to it'll pop at the top. Yeah, there you
Wait,
go.
is it up there now?
Let me see. Go
Yeah.
cook.
Okay.
Go
Okay.
ahead.
Yeah. Yeah. Somebody put in the chat. So if I want to put something in the nest, I should just comment it in this thread, right? And then do that same thing.
Yeah, that can work too if you don't want to go and like search for it.
Oh, dude, you're a legend, bro. Thank you, dog. Let me get a picture. So I'll get an exact picture of what people are doing. Okay, so people are using this picture as a representation of ancient cosmology. It's uploading right now. It's taking a minute because I think that it's because we're on the actual space. When people are reviewing the space, are they going to be able to check this out, these photos?
They should pop up under comments whenever the space is over.
Okay, okay. Bet. So if anybody's listening to this after the fact, make sure you do that. So essentially, let me get this popped up into the nest. Boom. Okay, can you see what I'm talking about? What I just popped up? The post I just made, Peter?
I see the perspective one from Zach. Maybe I need to reload something.
Maybe scroll to the right now. Grab his post and scroll to the right.
Oh, okay. Wait. Oh, okay. I see it. Yes.
Yep. So when you're looking at that, those depictions don't suggest that the sun is going below the sea level. You would agree, right? It looks like they're just going to go in a motion similar to what we predict currently in the modern day.
I I don't see how I would establish that. They're just pictures. Like, what direction does it imply that the sun is moving? I don't see.
It doesn't imply. Look at the Hebrew cosmology or like the Incan. Do you see the Hebrew and Incan model?
Uh. Oh wait. Okay. It's very low resolution.
Do you see
Okay.
it?
I see the Hebrew, and okay. Yes, I see the Incan. Yes.
Yep. So when you're looking at the Hebrew and the Incan, the sun and the moon, why would we ever think that the sun's going to go into the ocean or below the ocean in that model? When you're just looking at that from a common sense point of perspective, knowing about flat Earth, you would assume that that's just going to do a rotation around the Earth, causing day and night, right? So I don't get where you're coming from when you say that all ancient cosmology assumed that the sun went below sea level. I would completely and utterly disagree with that.
It might be worth trying to find some more objective type of evidence to suggest whether that's true of the Incan or Hebrew cosmologies, because I don't see that in the evidence that you're pointing to here. I mean, I would assume looking at these
So
that they believed the sun did travel below sea level, not into the
okay, so
water, but
that's a
behind the
positive
water.
claim, right? You're making a positive claim that they believe that. What evidence do you have that they
Okay,
made
I
that
mean,
claim?
I can't make that claim positively about specifically these two mythologies. I don't know enough about them. I would
Okay,
assume that
then
to be
yeah,
the case.
okay, then there we've got to. Okay, so yeah, they didn't. There's nowhere written down there where they said the sun goes below the sea level, and you'll never find that. So probably not an assumption that we should make. And so basically, in the modern day, so can we route back to the sun setting in the first place?
Sure.
Okay, so we would say that because of like if you look at Zach's model right here, where he's explaining perspective and everything going to a vanishing point, converging to a point, we would say that the sun is above us at 12 o'clock noon. It's at its zenith, right? And as it moves away from us, it's on average keeping the same altitude. But because we have a terrestrial perspective of a celestial object like the sun, as it moves away from us, it lowers and lowers in perspective by a certain degree with its uniform motion relative to one day. So it goes away from us and converges with the horizon.
Its size and its altitude, or its size and its declination, would both decrease according to an inverse tangent function.
And it does.
It does not.
It's just very slow.
I
So
measured it
are you
myself.
now
It's
saying the size
linear.
of the sun is uniform?
Yes, roughly speaking, yes.
No, it's not, dude. In your model, it's not because we see through an atmosphere, right? We only see the apparent size of the
Yeah,
sun.
okay,
We
but
already agreed on this.
the effect of refraction through the atmosphere is very minute. The rough size of the
No, it's
sun
not.
stays the same.
Do you know what? Have you ever seen like a super moon?
Uh, I think so. I mean,
Where the size of the moon is like insanely big because of atmospheric refraction. It happens, bro.
yes, okay, but when you're talking about atmospheric refraction, it does not produce an illusion of the consistency and nature that we see when the sun sets. When the sun sets, on most days, without like some extreme weather phenomenon, it sets while maintaining a roughly constant size and roughly constant angular rate. That does not agree at all with a flat Earth cosmology.
It does, bro. It's what we observe. Okay, so let's get on the same page as far as solar filters. Do solar filters increase or decrease refraction on objects?
Solar filters have no effect on the refraction.
You don't think solar filters have an effect on refraction?
Right. The refraction is happening in the atmosphere between your camera and the subject, not inside whatever filters you put on the camera lens. So the refraction has already taken place by the time the light reaches your filters. It has no effect. Unless you've got a bad filter where it's, introducing its own refraction, which would be very undesirable.
Okay, so when you're looking at, you're not seeing the physical size of the sun ever. Let's agree on that, right?
Correct. You're seeing its apparent size.
Okay. So if we're looking through a solar filter, mitigating the rays that are being emitted from it, and seeing the as close to what we can see as the exact position and size of the sun,
Mm-hmm.
why does it change size as it moves away from us?
It doesn't. Not really. I measured this myself.
But it does though. I've shown evidence that this does.
No,
What's wrong with the evidence that I showed then?
so in the video I saw from your TikTok
Hmm.
account, there
Yeah.
was there were two comparison shots, one where the sun was white with a slight halo of orange around it, and one where the sun was orange. Okay, and that's already a problem. But the other problem is that they were roughly the same size. It only changed by a couple of percentage points. We're talking about like okay, so just dealing with one thing at a time. In order to
But
see that,
hold on. Can I add something? I think it would help with the
okay,
context. So we don't know the distance to the sun, right? I don't know the true size of the sun either.
okay,
So how are we supposed to figure at what rate it should get smaller or larger
because
on
it
our
doesn't
model?
matter according to linear perspective. It doesn't matter. The angular distance or position in the sky and the angular rate of change should be the same if you're I mean, okay, so if you're talking about an object traveling toward the vanishing point on the horizon, that object is going to lower its declination according to an arctangent function, as I mentioned, and it's going to get smaller according to an arctangent function. It's going to have whatever starting, whatever angular size and angular position it had to begin with. Those are going to change according to a predictable function. You don't have to know the physical distance. You don't have to know the physical size, but if it's traveling directly away from you, it should follow that function.
Okay, would you say that using geometry would be a good way of figuring out the linear expected angular size change?
Yes, that's exactly what I'm doing. That's why I
Okay.
mentioned
So does
arctangent.
geometry use triangles?
Often, yes, that's the sub uh, section of geometry called
Okay.
trigonometry.
Okay. So if we only have one length of the triangle, meaning we don't have the distance from the observer on the surface of the earth to the sun, if we don't have that length of the triangle or the length of the triangle from the sun back down to the earth to another position on the earth, can you see why we can't figure out that angular size and what we should expect the
No,
change to
no,
be?
because it doesn't matter how big the triangle is. We know two of the angles, okay? Because you're saying
Okay, but hold on. I don't think you're listening. I don't think you're understanding. I'm saying we don't have two angles. We need at least two angles of the triangle in geometry to figure the
we
distance,
do have
right?
two angles. We do. Because you're
Okay,
saying
so what two angles do we have in the triangle?
we have the angle we measure at one corner of the triangle, which is our, the angular position from our vantage point, and
In
the
relation
other
to what?
in relation to the horizon, or whatever your reference point is.
Okay, let's make it simple. Let's say we have two coordinate systems on the surface of the Earth, and we assume that the Earth is a rigid body. And we have one position of me, and we have another position of you, where we have one line. Then, right, we can agree, let's say we agree on the size of America, or the size of, let's say, California. You're on one side of the California border at the shoreline, I'm at the other side of the California border, and let's just, in a hypothetical situation, say that we can see each other. And we don't even have to see each other. We know that distance because we can drive it, right?
Okay,
And we can figure it out in miles, correct?
sure.
Okay, so we have one line of the triangle. We have one line. That's
Well,
it.
you're drawing a
We
different
need
triangle than I thought we were talking about a second ago. I was just
Okay.
talking about one observer, not two.
Okay, but you can't have an angle from one observer unless you have a decided point somewhere
Well,
else
right,
on the
the
surface of
horizon.
the
We're
earth.
talking about sunset, right? So the horizon forms
But the
one.
horizon is apparent.
Yeah,
So that's why it's more logical to
it's a
like
fixed
pick a
point on our.
position.
It's a fixed point on our celestial sphere.
No, it's not. It changes. The horizon changes with the atmospheric conditions, right? It gets taller or it shrinks and it shows less or more, right?
No, that's stuff over the horizon. The horizon itself is. I mean, it's roughly fixed. It's roughly at eye level when we're on the
Okay, so
surface of the Earth.
don't you think it'd be much more of um, a solid assumption or a solid experiment if we had 2 points that we decided, me to you, on a fixed rigid body, meaning the Earth, and the distance between us was agreed on, right?
It sounds almost like you're trying to figure out how far away the sun is. I didn't think we were doing that. I mean, if that is what you're doing, then yeah, that's a good methodology. But no, I
Yeah,
got
that's exactly what I'm saying, because we, in geometry, we have to basically, to figure out the angular change of the size of the sun in relation to a viewer on the earth, we would have to know the distance to be able to calculate the angular size change.
no, I don't think we do. I think we can do
Why?
that with one observer, and I think that's the best method because it doesn't
That's
matter.
not geometry then, though. You're not using,
Yes,
you
it
said that
is.
geometry, no, no, geometry is using triangles. So
Yes,
you
there
have
are
to have,
triangles on the celestial sphere. You don't need two observers.
how do you make a triangle with one observer?
Because you can measure where something is in relation to something else that you see, like the horizon. So that you can say from one vantage point, you can say how many degrees above or below, well, not below, how many degrees above the horizon the sun is. You only need one observer to do that. And you
Okay,
can
but
use the sextant.
if the horizon is apparent, how do you know that that apparent position where you're looking out to the horizon won't be in a different spot tomorrow or the next day?
It doesn't vary that much, okay? We're talking
It
about,
does. It can some days. It can be
no, we're
very drastic.
only by like arc minutes or arc.
No, it can change during the same day. There's time lapses of the horizon changing drastically over one day.
Yeah, by a matter of degrees or arc minutes, not
Okay,
by.
so that would make the assumption or the apparatus that you're setting up or the observation that you're setting up unreliable.
No, because okay, first of all, it doesn't even matter whether you can like see the exact horizon visually. You can also measure gravity by using a level. Just
Mm-mm.
basically a little piece of glass with some fluid inside and a little bubble with the center marked. If you center that bubble, then you know that your apparatus is upright in relation to whatever term you want to use for the force applied downward to all matter. Okay, so once you do that, then perpendicular to that force is your eye level on your celestial sphere. Whether you can see it or not, whether there's trees in the way, whether it's bobbing up and down according to atmospheric refraction, it doesn't matter. If your apparatus points in a consistent direction because of gravity or
Okay, well,
falling or
let's
whatever.
not go on to gravity again quite yet. I'm fine to talk
Okay,
about gravity more,
well,
but we're
whatever
talking.
term you
So,
want to use.
okay, but basically, what I'm saying is you can't create a triangle with one observer
You
because,
can.
okay,
You
but even,
absolutely
okay, hold on,
can.
hold on, listen to me, Peter. So if we're using, let's use what you're saying, your observation or your suggestion. We have one observer and we're looking out to the horizon. That's only one length of the triangle.
You don't, yeah, it's an angle. You don't have the length, you have the angle, and that's the important thing.
No, no, no. What in the angle can't be created because we don't have a vertical angle.
The vertical is the opposite leg from our corner.
In
Okay,
relation to what though? You have to give a coordinate system. In relation to what?
it doesn't matter. It's okay. So you know horizontal that provides the angle of like the adjacent leg of your right triangle. Okay, and then
Hmm.
the other angle, which is where you measure the sun to be, that is the direction of the hypotenuse.
Okay, so you're
It,
saying that the vertical angle just goes forever, right? And you're just getting that angle on relative to out
yes,
to the
yes,
horizon. Okay, I get what you're saying, but that's not completing a triangle. You have to have two angles.
yeah, because the other, I mean, if you're assuming that the Earth is a plane, then the Earth itself provides that leg of the triangle, and um, the well, it
Hmm.
does anyway, whether the Earth is a plane or not. But then there's the opposite leg of the triangle is basically assumed, and then that provides the 90-degree angle opposite from you.
Wait, what do you mean? Elaborate. Specificity, please.
So you're saying that the sun travels at a travels
No,
horizontally
no,
at
let's
a
keep talking geometry. So what I'm saying is we can't basically my claim is we can't make the triangle. So we can't use trigonometry, right? We cannot create two angles which are needed to find the distance or the lengths of a
where
triangle.
we can define one of the angles that to
One
be
angle.
90 degrees.
Do we Okay, let's agree on this. Do we need two of the angles to figure out the lengths of the triangle?
We don't need to figure out the length of the triangle because we if we have one angle and we define it to be a right triangle, that means the other angle is 90 degrees. We have a triangle, and the lengths don't matter because it's going to be congruent to whatever triangle we define.
We're not using geometry then, bro. Like we must be disagreeing on the core tenets of geometry. Because you have to have two angles of the triangle to figure out the lengths of the distance, and we're trying like would you okay how do we okay so in your model how do we figure out the sun is 93 million miles away?
Well, that requires parallax and things. I mean that doesn't even matter to
It
what we were
doesn't.
talking about, because what we were talking about is
Okay, but
whether
I'm trying to get to a agreement that we can't figure out the distance to the sun accurately. How do we accurately figure out the distance to the sun then? Or maybe I don't want to straw man you. Do you think we have the accurate distance to the sun measure?
I think we do, but that's a different subject. You're changing subjects now. I
No,
thought
it would help with our subject because if you're accurate, then you could easily prove me wrong in assuming that it's not 93 million miles away and it's more local. So how do we figure the distance to the sun then accurately? Because I don't think we can,
that's
but you
still a
do.
that's still a different route to disprove flat Earth theory than I thought we were taking here. What I
Well,
was
there's
saying.
no disproving flat Earth theory.
Okay, all right, whatever. That's a different subject of the debate. You
No,
know,
we're talking about the sun and the distance to the sun.
no, I was talking about whether it sets, whether it travels
Okay,
below eye
yeah,
level.
yeah. Okay, but if that, then you like, would you agree that things that are directly above us are at our zenith? Let me post something. Hold on, let me post something to the nest real quick. Let me post one of my graphics right quick here. This should hopefully we should be able to agree on this, and if not, it's all good. I don't expect us to agree on everything, but okay, right here, add post. Okay, give it like 10 minutes for whatever reason while we're in the in the space. It takes a lot longer to post it. But like I'll wait for it to post, and then it's much easier to use like graphics when talking about this
Sure.
because we're talking about how we view reality and stuff like that. So I'm curious to see if you would agree with this. So basically grab
By the
this.
way, I really appreciate this. Like, I've met a few different flat earthers in the past several years, and almost all of them that I knew personally just kind of ran away from talking to me about these things. So I appreciate this. Like, this is This is really good to me. I
Yeah, dude,
appreciate
you're extremely cordial, and I've been bad in the past, but I've had a lot of people reach out to me and say, you know what, man, hey, like I'd appreciate it if you were just like more cool, like more collected when talking to people. So I've made it a really big thing to not like try to be rude or condescending. I try to have honest conversations and really try to understand your guys' position in hopes that you'll try to understand mine just as much. You know what I'm
Thank
saying?
you. And
So
especially if you are a Christian, because I know you mentioned the Bible, like, then
I'm
this
not.
should be
I'm just spiritual. I just believe in God, but I think the Bible is an awesome book. I think the Bible is, and I think the Bible
all
is
right.
how I look at it is basic instructions before leaving Earth. I think it has great core tenets.
All right. Well, a lot of, as you know, a lot of flat earthers are Christian, and in
Yeah,
my mind, that should be, you know, that gives me, for example, that much more incentive to be cordial to those people because we agree on something so important. So
yeah.
like, and it should be vice versa, and often is, I hope. But
Yeah, I don't think I used to get really triggered and think that this was that type of a topic where you should just jump down people's throats and stuff
yeah,
like that. I've completely changed my view on that. It just looks bad. So I'm very much against that now. If I'm gonna get triggered, I'll usually just let somebody go so I don't get angry with them. But you're pretty chill. So I've had no problem with you. If you look at, do you see what I just posted to the
yes,
nest?
I see it.
Okay, so you would agree if there were a telephone pole that we telegraph pole that was right next to us, right? It'd be straight up and down. It'd be at a zenith position, right?
Yeah, if we stepped over and stood under it, this
Yes, exactly. Yep, exactly. And then as you look down the line of telegraph poles, let's just assume they all are rigid. They're all the same height. They're all the same dimensions. Okay, which is usually typical to keep them parallel. So if we assume that all those telegraph poles are the rigid bodies in relation to each other, meaning the exact same uniform, as they move away from us with distance, they lower in perspective or they get smaller, right?
Yeah, they would do both, lower in declination,
Yeah.
that's angular position, and then they would also get smaller at the same time.
So if we apply the same logic to the sun, at 12 o'clock noon, it's at the zenith, similar to us sitting right under that telegraph pole, right?
Yeah,
And as it moves further and further away, it lowers and lowers in perspective until it eventually reaches the vanishing point or the horizon. That's how I would view it. I have another graphic I'm actually going to share right now too and put up in the nest, but I'd like to know your thoughts on that. What do you think of that?
so the thing is, when you say reach the vanishing point, I think we already have a problem,
Okay.
because if an object travels infinitely in that direction, theoretically, if you had a perfect lens or a perfect telescope,
Mm-hmm.
and there was no atmospheric turbulence, no obstacles in the way, you could always zoom in and find it again. Because when it disappears over the vanishing point, just from traveling straight away from you, that what that is not it, like, being obscured. It's what that is it getting too small for you to detect. So it's still there. It's just too small. It's smaller than the pixels in your image or whatever.
Okay, but there's a limit to that angular expansion, right? There's a limit to all perspective, right? So even a telescope, even a P1000, it can't zoom forever, right? There's
Right,
a
but
limit.
long before that happens, long before you reach that limit, the sun, if it were doing what you're describing, it should become smaller than the stars in the night sky and remain that way for a long time while it continues to recede.
I get what you're saying. I totally get what you're saying, Peter. I would disagree with you because I don't know the size of the sun or the distance to the sun, so I
It
can't
doesn't
calculate that.
matter what the size or distance are. It doesn't. I swear to you, it does not.
Okay, but in my opinion, it does. I think that
It's
hold on, to
okay.
figure out the expectation of the angular size rate change, we would have to know the distance to the sun as well as the size of the sun to accurately figure that out. So, in my opinion, because we have this hemispheric dome that we see in, right? Like Stellarium uses this same data where they basically we create a dome-like vision, not anything to do with the dome of the earth, anything like that. This is agreed upon in mainstream science that we see in like a hemispheric dome, right?
Yeah, it's called the celestial sphere. That I've been
Yes, the
talking about it.
celestial, exactly. I'm glad that you know about that. So that celestial sphere limit is much that the distance that the sun has to travel to go out of that hemispheric dome. That, what do you call it? I like how you say it. What did you call it?
Celestial sphere.
The celestial sphere that we see in, it leaves that limit of perspective of the celestial sphere much faster than the angular size change would change to like a point, you know. That's my
No.
stance. You can disagree with that. That's totally fine. I just wanted to make my position clear to the
Okay, but
audience.
it's not a matter of me disagreeing. It's a matter of it seeming incoherent to me.
Why? Why is it incoherent?
Because it getting smaller than a star, like I was describing, that is it leaving that celestial sphere. There is no such thing as it leaving the celestial sphere by getting too far away, unless it goes through that process of getting smaller than the stars in the background, or
Okay,
whatever.
so we agree that things get lower in perspective over distance, right? With the telegraph poles.
Yes.
So I guess we need to agree why there is a horizon. Do you think that there is a horizon purely because the Earth is curved?
No. There's a horizon because the land that forms, the land below the horizon doesn't rise above that eye line unless you're near a mountain, in which case you can't see the horizon. But the horizon is because um it's just a matter of like, if you take a celestial sphere observation from any point in space on the surface of a sphere or on the surface of a plane, in either case, half of that celestial sphere is going to be obscured by the shape of whatever your Earth's shape is, unless that shape was somehow concave instead of convex. Then it would form an eye level orthodrome on your celestial sphere and fill that bottom hemisphere of your celestial sphere.
So you do understand that most people in the argument right now today, anti-flat earthers, people like that, would disagree with you. You realize that, right?
How so?
They say that there's only a horizon because the Earth's curved. That's the position right now.
Maybe they don't understand science then.
Yeah, I would agree with you. No,
I,
I think you have a very based opinion on why there is a horizon. Hold on one second. Sorry, I put in headphones because I thought I was bothering my girlfriend, but she wanted to listen to our conversation, so she told me to take them out. Okay, so that's exactly what a lot of us are trying to like expose, Peter. If you listen to people like FTFE or McToon.live or whatever, any of these really anti-flat Earth people, they will say that there's only a horizon because the Earth is convexed, that there's an average rate that it lowers it relative to and tangent from somebody on the surface of the Earth. That's what they're saying right now, and
I've never heard that position
it exists. I
personally.
promise you, it exists.
Okay, I
Yeah, yeah.
trust you. It sounds incorrect
Yeah,
though.
it is. It's demonstrably incorrect. So I think we agree on that. I guess I don't know if we're going to come to an agreement. Well, I mean, we should. If you agree with point perspective and you agree that the horizon is apparent, right, and it's a position where the sun, or sorry, the sky and the ground appears to meet, and it creates an apparent horizon. Doing that, I don't see why you have a problem. And knowing that we see in a celestial sphere and knowing that, I don't see how you can't come to the same conclusion as me that if the Earth were flat and the sun moved uniformly at the same rate relative to 24 hours, it would get to a distance far enough away that it would converge with that vanishing point. I don't see how we're disagreeing with that.
Because the vantage point is where the parallel lines converge at infinite distance. The sun doesn't travel an infinite
Well,
distance away, especially not like in a finite amount of
look at
time.
the
There's just no way.
look at the second post that I made, right, with the telegraph poles and the railroad lines, right?
Yeah.
You would agree that
Okay.
those railroad tracks look similar to how it looks in reality, right?
If you're how a railway line looks in reality, sure.
Yeah.
Not the sunset, but yes, the railway line, yes.
Okay. So as we look towards the horizon, tangent from our view, it looks like they converge at the vanishing point. Do you see how it looks like they're touching?
Yeah, because they're so far away at that point that they're smaller than the grains that compose the image.
Right, but they don't have to be infinite, right? To appear.
Right, but in order to form an actual vanishing point, you do have to get far enough away that it's smaller than the grains that form the image. If it doesn't, then it's not going to form a vanishing point unless you continue to draw the lines past where it changes direction or whatever.
I think I agree with you on that. I think I can agree with you there. But that's how we see in reality, right?
Yeah.
Okay. So so no, I don't know if that's really complicated. I've never heard somebody go at it that way. I like how you're saying that. That's making me think. But I don't think so. Essentially, like the same thing would happen with like a boat, right? So a boat doesn't have to get to the size of a grain of sand to go over the horizon.
Well, that's correct, but I
Go past
believe
the
that's
horizon of
because
view. Sorry, not over the horizon. There's not a boat.
I mean we have we have photographic evidence all over the place of boats disappearing over the horizon from the bottom up, like
Yep.
almost like a puppet show, like sliding, so that the bottom half of it is obscured before the top half.
Yep.
And you can still see it. It's not infinitely small,
Yeah. That's what I'm trying
and
to say.
so it slides down over the horizon. That I can only understand how that could make sense on a globe Earth. But
Okay, but what do you think of the videos where people have taken a P1000 out and zoomed them back in and see the bottom again?
what
Have you
videos?
seen? Have you never seen a video of like that?
I mean, I remember hearing. It's been a couple of years since I did in-depth research on flat Earth theory. I
Hmm.
remember hearing a couple of claims that could be done,
Yep.
and I remember seeing what I thought was garbage evidence of, like, it was not what they were describing at all,
Okay.
or something like that. Eh, eh,
Can somebody share? I know somebody in the chat probably has a video in their camera roll. Can somebody share that an observation of us zooming back in a boat? Because you would agree. Okay, so oh, I just found one actually. I just found one. Let's add that. Post that.
Let me be
Okay.
clear before I see this, like,
Yep.
so that we can agree on rules of falsification versus rules of proof. Okay,
Hmm.
if the boat, quote unquote, disappears over the horizon in the sense that it gets too small for us to detect in the pixels of the image, or whatever, that is an example of what I was just describing with the railway lines, where it's disappeared to our vanishing point, by just getting too small for us to see. Okay, that is not the same as what I just described, where the boat like slides down where the water is obscuring the bottom half before the top half. Okay, those are two very separate ways
Okay.
that a
I
boat
think
can disappear over the horizon.
I think before we go over the video, then we need to agree on something. So if a boat is not visible to somebody from the surface of a shoreline, has it gone over the curvature of the earth?
That depends. That
Why?
depends on whether the boat is um, still, like, whether there's technically still a line of sight between the observer and the boat, but the boat is so far away that the observer, with their current tools available to them, or their current, like what they're currently looking with, whether it's too small. So if they're using a camera, if the boat is so small that it's smaller than a pixel on that camera, or if they're using their eyes, if it's too small, for a cone cell in their retina or whatever, if it's simply too small because it's too far away, but there's still a line of sight, then no, it has not technically gone over the horizon. It's just too far away.
Okay, so I agree with you. I'm on the same page as you. I actually agree with you here. But what I think that you'd be shocked to find out is a lot of globe earthers will adamantly disagree with you on this. I've had
I
this
think
debate.
that's probably because you debate with a lot of people who don't understand the math and science behind the globe Earth.
I debate
Just to be frank.
physicists. I debate physicists. I've debated PhDs. I debate people well in academic, authoritative academic positions.
All right.
I
Well,
don't
then
just
maybe
seek
there
out.
was some misunderstanding or something. I don't know. I don't
Okay.
know, but
Well, if you listen to people like Bill Nye, Neil deGrasse Tyson, the top astrophysicists of today, they will say solely that you can't see a boat anymore because it has gone physically over the curvature of the Earth. That's their claim. They don't claim it gets too small, and that's not. They literally say boats disappear from the bottom up because the Earth is curved. That's the current claim.
well, that thing you just said, I agree with. The only way that a boat can disappear from bottom up, where the water is obscuring the bottom half of it before the top half
Yep.
over the horizon, the only way that can happen is by curvature of the Earth.
I get that. I get your position there. But the problem is then you would have to assume that every boat that is not visible to the naked eye has gone over the curvature of the Earth, right?
Unless it's just too small, and if you used a telephoto lens
But
or
that
something.
that's where we're having the disconnect here, because on their side they would say yes, if you can't see a boat from the shoreline for with your naked eye, it's gone over the curvature of the Earth. Assuming that if that person stood there and had filmed it with the same resolution that their eye has, that it would be going over the curvature of the Earth, right? So we shouldn't be able to zoom it back in.
Okay, I'm sorry. I kind of zoned out for just a second while you were talking, and I kind of lost what you were saying. I'm so sorry.
No, you're good. I'll repeat it. So basically, if we were at the shoreline and I had a camera that exactly mimicked how you view reality, we put it the same observer height and everything, and we watched a boat disappear from the bottom up with said camera on film, you would assume that that went over the curvature of the Earth, right? And we shouldn't be able to see it anymore.
I mean, not necessarily. Like again, if it disappears simply by shrinking to smaller than a pixel, then no, I wouldn't necessarily assume it's gone over the horizon.
But that's not what we ever observe. And boats never shrink to the size of a pixel to be disappeared. We can
It
plainly
it
see
just
them.
does it in this video you just posted if you played it in reverse. Like it's obviously, zooming out instead of zooming in, but like if you took this video and played it in reverse, that exact thing would happen. Um,
Okay.
the boat would,
So
or wait,
so
maybe
things don't disappear so you would agree that things could disappear from bottom up on a flat earth based on angular resolution then.
no,
Why?
because that's incoherent. How could they?
Because they shrink to a point.
That's different than disappearing from the bottom up. That's different.
How?
How is it the same? You're talking about one thing where you can still see
We
the
can
top
observe.
half.
So okay, so let's say we have a camera on a 1 foot observer height. Actually, let's put it on the surface of the Earth, a camera at a football field, and there's videos of this. And we walk away from that camera. We disappear from bottom up. We don't shrink to a dot. We disappear from bottom up quickly because it's on the surface of the Earth. That same phenomena I'm claiming happens with the sun.
I'm sorry, I'm having trouble following what you're saying.
Okay, no problem. So if we have a camera, right?
Okay.
That is a very wide angle. And let's assume that it sees in perfect Euclidean, just for the sake, and it's not possible, but just for the sake of the argument. If it's on the surface of the Earth, touching the surface of the Earth, watching you walk away from it, you will disappear from bottom up based on perspective, not because the Earth's curved. You would agree, right?
No, I would not agree.
Okay. Why do we disappear from bottom? So let's say the football, you would agree that football fields are relatively level. They level them, right? They're not curved over
Uh,
100 yards.
I mean, yeah, the curvature of the Earth on that scale is essentially negligible. So yeah, sure.
Yeah. Okay. So why would we not be disappearing from bottom up due to perspective?
Because that's not how perspective works. Things don't disappear from bottom up by traveling straight away from the observer. According to linear perspective, that doesn't happen.
So what's wrong with my apparatus then? What is happening? What explain what is happening when somebody puts a camera on the surface of the Earth and walks away from it and disappears from bottom up? What are we watching? What is going on?
Uh, Maybe I'm picturing it differently than you. I don't know exactly what you're picturing, so I can't tell you what's going on in what you're. I mean, if there was a video we were looking at, maybe I could tell you.
Okay, let's say we're at the 50-yard line. Okay, we put the camera down on the ground. It's literally let's say it's like dirt. There's not grass or anything either, and
Okay.
and we walk away from it. As we walk away, you will disappear from bottom up, meaning your shoes will disappear first, then your legs will start to disappear based on the distance. It's not going to
So
happen drastically, but it will happen.
so you're talking about there will come a point where your like below your waist is obscured by the horizon,
Yes.
but above your waist, you are still larger than a pixel in the camera's view, right?
Yes.
Okay, that cannot happen on a flat Earth
Why?
unless the dirt was not level. Maybe if there's a hill that you walk behind, then it could happen. If you go behind the hill, then you'd be obscured by the brow of the hill. But just based on
You
pure Euclidean geometry, if you're talking about an infinite plane, something traveling straight away from the observer, in a straight line along a plane, as it shrinks due to perspective, it will never be obscured halfway by something that's not even breaking the line of sight between the camera and it. That's not a thing. That's incoherent.
Okay, so we can not say that things disappear from the bottom up because of the curvature of the Earth, because things do shrink smaller when they get further away from us, tangent to our position, right?
I'm sorry, I had trouble understanding that sentence.
So we
Were you
can't
asking a question?
ad hocly assume that things disappear from the bottom up relating to people or boats. In your theory, we can't say that it's happening because of the physical curvature of the Earth, because they do seem to shrink very small, right?
What I'm saying is that if something is disappearing from the bottom up so that the bottom half is obscured while the top half is still larger than the grain of resolution of your image,
Yep.
what that means is that something has to be blocking the line of sight between you and the object, and then the bottom of the object. There is no other physical way that can happen.
Okay. I think that we're at a philosophical impasse, brother. This
This
conversation has
is
become extremely circular.
this is pure geometry. It's not even philosophical.
It's not geometrical. I mean, in a way, it's basically comparing Euclidean to hyperbolic geometry. But I think that we'll have to have a further conversation, bro. We've been talking for like an hour, a little bit over an hour. Do you mind if I talk with another guest?
Not at all. But I would love to follow up with you if you're
Yeah,
willing.
yeah. No,
This has
I'm
been
gonna
fun
be
for me.
doing this more often. So make sure that you follow me, and I'll be starting these live debates much more often over here on X. I'm probably gonna start to transition over to here rather than TikTok, because I like the anti-censorship. So
Okay, cool.
cool. Thanks for talking, Peter. Hope you have a good night, man.
Thanks, you too.
Yep, later, man.